Hi guys, this is our last set of notes for our digital notebook for this little unit. So the last set of notes you're going to add into your table of contents, slide 16 and 17, we're going to solve radical equations. So we're not going to have fractions this time, we're going to have radicals. So like square root, cube root, those kinds of symbols. Need a piece of paper, you can title it up at the top, Notes 2B.2.2, Solve Radical Equations. You don't have to write down the essential question, but basically at the end we want to be able to know how do you solve radical equations and what cancels out a radical. So since we have equations today, equations means you're going to be trying to find what the variable is equal to. So find what number the variable equals. We're going to write down some steps. These will help you when you guys are working on your problems for your homework. The first thing you want to do is isolate the radical on one side. So first you want to move anything that's being added or subtracted outside. Then you want to cancel your like adding and multiplying or dividing. Step 2, once your radical is isolated, that might take like a couple of steps. You might have to add a number, subtract a number. You might not have to do anything at all. It might already be done for you. The second step is to raise both sides of the equation to the power that will cancel the radical. So raise both sides of the equation to the power that will cancel the radical. So if you just see a square root, that means you're going to use a power of 2. If you see a cube root, that just means you're going to use a power of 3. If you see a fourth root, you're going to use a power of 4, and so on, right? The pattern just continues. Whatever they call this number right here, it's called the index. So whatever your index is, your power is going to match it. All right, oops, still on highlighter. Step 3. Step 3 is to go ahead and solve the resulting equation. And the last step is really important, and it is to check that your solution is valid. Some examples when it would not be valid is if you have the square root of a negative number, or if you have the square root of something equals a negative number. Okay, so those are some options of, what would tell you that a solution is invalid. Okay, so this is what we're going to put onto our slide. We have a lot of examples. We have 5 examples we're going to go do. So I need you guys to get your workbook. You're going to open to page 59. So page 59 is where our examples start. So we're going to work on page 59. Sorry, I had to find my workbook to see what page it was. Okay, so our problem says, example 1, solve the radical equation, square root of x minus 5 equals 2 for x. So the first step is to isolate your radical equation, right? That's already done for us. This is the radical. There's nothing outside of it. There's nothing being added or subtracted. There's nothing outside the radical, so that step's already done for us. Check, we're good to go. Okay, then step 2 says to raise both sides of the equation to the power that will eliminate the radical. So since it's just a regular old square root, we raise both sides to the power of 2. What happens when you do that is the radical and the square cancel each other out, so you're just left with x minus 5 equals 4. Step 3, the next step right here, is to just solve the resulting equation. So we're going to go ahead and get x by itself by adding 5. We get x equals 9. Before I put a box around my answer, I just double check that it works, verify that the solution is true. So the original problem was x minus 5, so we're going to plug in 9 minus 5 equals 2. That's the square root of 4, and indeed the square root of 4 is equal to 2, so this answer works. Put a box around it. It's good. All right, let's flip over our notes or our workbook to the next page, which is page 60. We have a bunch more examples to do here. Okay, so it says solve the radical equation, square root of x minus 5 equals 2. So this looks really similar to the last problem, right? Here, though, the 5 was under the radical, and in our new problem, the 5 is not under the radical. Okay, so that's the difference between the two. So if it is not under the radical, we actually have to move it. We have to isolate the radical to get it by itself. The way that we do that is the inverse operation. So we're going to add 5 to both sides to get the square root of x equals 7. The next step is to raise both sides to the power that would cancel. So we get x equals 49, right? The square root and the square cancel each other out. So you're just left with x equals 49. Before I put a box around my answer, I do double check to make sure that it works. I get square root of 49, which is 7. 7 minus 5 equals 2. Check, it works. So this is just my little check to make sure that it's true. All right, let's go to example number 3. It says solve the radical equation, square root of 2 minus x equals x. So the first thing we would have to do would be to isolate our radical. Well, this is our radical piece. There's nothing outside of it. There's nothing being added or subtracted, so we get to skip that step. Step 2 is to raise both sides to the power that would cancel it. So since it's just a square root, we're going to square both sides. So it cancels, and we get 2 minus x equals x squared. All right, so we have to think back to what we did last week, and if you recall, if you have an exponent, you have to get one side equal to 0, try to factor, and solve. So we get 0 equals x squared plus x minus 2. That problem can be factored via snowflake. There's no GCF or anything, so you multiply a times c on top, b goes on the bottom. We need two numbers that multiply to -2 but add to 1. Well, the only thing that multiplies to 2 is 2 and 1. Since it's a negative on top, 1 has to be negative. 2 minus 1 is 1. So I took this polynomial right here and I factored it. And I got x plus 2 times x minus 1. So then my two answers, what you get when you set each of those equal to 0 and solve, x plus 2 equals 0, x minus 1 equals 0, you get x equals -2 and x equals 1. Before I put a box around my answer though, I do want to do a little check to make sure that they would work. So in the original problem, if I plug in -2, 2 minus -2 equals -2 because there's two x's. So I'm plugging it in right there for both. When I do that, I get square root of 4 equals -2. Well, that's not true. The square root of 4 is +2, so this answer doesn't work. Then if I try the other one, 2 minus 1 equals 1. The square root of 1 equals 1. Check, that one works, so 1 is our answer. So to recap, if you do get a square, this problem had a square in it, you have to get one side equal to 0, try to factor it, if you have to do snowflake, GCF, whatever it might be, then set each factor equal to 0 and solve, but double check to see if they are valid solutions because this one gave us an untrue statement, so this answer didn't work. But the one was good, that one checked out, so that was our answer. All right, example number 4, okay? So what we have here is we have the square root of x minus 7 equals 3 square root of 2. All right, so for this problem, ladies and gentlemen, we have a radical equal to, and then there's a radical on the other side. Since those radicals have different pieces underneath, we can't combine them together. So there's no way to isolate our radical because there's two of them. They can't be combined together because they have different things underneath. So what we're going to do is we're actually going to just square both sides. I'm going to put this side in a parenthesis because I want to remember that when I square it, I have to distribute that square. So my square root and my square cancel, so I get x minus 7 equals. The 2 gets distributed, so 3 squared is 9. times the radical and the 2 will cancel, so that will just be a 2. Now I no longer have any radicals. I just have x minus 7 equals 18. And then I add 7 to both sides, and I get x equals 25. Before you even turn in your homework or we go over the answers, you should be able to check to make sure that your answer was correct, because you could plug it back in. The square root of 25 minus 7 equals 3 square root of 2. Well, the square root of 25 minus 7, 25 minus 7 is 18, equals 3 square root of 2. Well, 18 is the square root of 9 times the square root of 2, and the square root of 9 is 3. So 3 square root of 2, check, it works. 25 is a good answer. All right, let's go to example 5, and we're going to change it a little bit. We're going to go ahead and just get rid of this square root of 5. So if you guys can just cancel that part out. We're not going to get into problems where there's 3 radicals like such. We're just going to go ahead and solve this one like we solved the last problem. Okay, so I'm going to square both sides just like problem number 4, because there's a square root on both sides. They have different pieces underneath, so we can't combine them together. Okay, we can't combine them together because they have different pieces underneath. So then we cancel out our squares. Our squares and our square root cancel, so we get x equals 3x plus 5. We're going to go ahead and solve. Okay, we're going to subtract 5 on both, no, not subtract 5 on both sides. I'm going to subtract my 3x to move it to the other side. I get negative 2x equals 5. Divide both sides by negative 2. I get x equals, positive divided by negative is negative. 5 divided by 2 is, can't be simplified the fraction. You could do a decimal if you wanted, negative 2.5. Then before we put a box around our answer, we want to do a little check to see if it is true. If it works, we get the square root of negative 2.5 equals the square root of 3 times negative 2.5 plus 5. Well, right here, automatically, right off the bat, I notice that it says the square root of a negative, right? So this is an imaginary answer, and we're dealing in the real number world, so we're going to say no real solution. So we had an invalid value on number 3 because when we plugged it back in, it was equal to a negative. Here we had a negative under the radical. So both of those cause answers to be invalid. So there was only one answer. It didn't work. We would say no real solution. All right, last one, number 5. So this is the only problem that actually has something other than a square root. We have a cube root. Okay, so here is my cube root, is this piece right here. The cube root of 3x plus 6. Okay, here's my equal sign. Is there anything on the same side as the radical? Yes, there's a 10. So we have to move that 10 before we can do anything else. So I'm going to subtract that 10 on the both sides. I get the cube root of 3x plus 6 equals negative 3. All right, well, the way that we get rid of a cube root is we raise both sides to the power of 3. So cancel, cancel. So we get 3x plus 6 equals negative 3 cubed. So negative 3 times negative 3 times negative 3. That's going to be negative 27. There's no exponents or anything, so we can just solve by isolating our variable. I'm going to subtract 6 on both sides to get negative 33. Divide both sides by 3 to get x equals negative 11. Before I put a box around my answer, though, I do want to check to make sure that it is a valid solution. So I get the cube root of 3 times negative 11 plus 6 plus 10 outside the radical equals 7. So just right here where my x was, I'm plugging in the number negative 11 because that's what we found x to equal. So I get the cube root of negative 33 plus 6 plus 10 equals 7, not a square root. Underneath the root, I have a negative 27 plus 10 equals 7. So I know you guys are thinking, well, you can't have a square root or the negative under the square root. You can't have a negative under a square root, but you can have a negative under the cube root. So if you took the cube root of just regular 27, it would be 3, but the cube root of negative 27 would be negative 3, because negative 3 times negative 3 times negative 3 is negative 27. So if you're taking a root, okay, if you have a negative underneath, as long as this number is odd, then it's okay. Okay, so as long as the number is odd, then it's okay. If it's even, not okay. All right, then we have negative 3 plus 10 equals 7. 10 minus 3 is 7, so check, it works. That answer is correct. Okay, so it's okay if you have a negative under your radical as long as your index, the number on the outside, is negative. I'm sorry, odd. All right, so this is going to be one of our pictures for our notes. The note part that we took is going to go on slide 16. Nothing goes on the right-hand side. Then you're going to put page 59 on the left and page 60 on the right of slide 17. If you forgot to do your table of contents earlier, the title is right there on your slide. Okay. All right, you're going to do some practice out of the workbook on solving radical equations.